20. Number 98. What is the most accurate name for the quadrilateral with the coordinates listed? Okay, our choices are trapezoid, rhombus, quadrilateral, and parallelogram. All right, let's see what this shape looks like. Take a moment now, go ahead and graph it. I'm going to zoom in and I'm going to graph. So here we are. Our quadrilateral is graphed. Now I'm looking at this and I can tell just by looking at it that this is not going to be a trapezoid. Now, to know for sure, you want to check the slope. You want to check the slope of the opposite sides and check to see, are the opposite sides parallel? Let's look at the top and the bottom. So if I start with the point on the left, I go up 1, I go to the right 4 boxes. So up 1, right 4. So my slope for the top is positive 1/4. For the bottom, if I start on the left point, I go up 1, right 4. So again, my slope is 1/4. So I know the top and bottom are parallel, which still means it could be a trapezoid if you have one pair of sides parallel. But let's look at the left and the right. So for my left point, again, I'm going to start with the left side and the left point. I'm going to go up 1, 2, 3, 4, and right 1. Okay, so for the left side, my rise is 4, my run is 1. Let's look at the right side. Up 1, 2, 3, 4, right 1. Okay, again, my slope is 4/1. So that means both pairs of sides are parallel. If we have two pairs of sides parallel, that means at the very least, this is a parallelogram. So looking at my options, I'm going to start crossing some things out. So with my options, I'm going to cross out that it's a trapezoid, because that means only one pair of sides would be parallel. I'm also going to cross off quadrilateral, because it's more than just a quadrilateral. It's actually a parallelogram for sure. Now I want to check, is it a rhombus or is it just a regular parallelogram? For a rhombus, the one thing that I can look at is, are all the sides congruent? That's one of the easiest things to check. So for a rhombus, I'm going to check to see if all sides are congruent. All sides congruent. Something else I could check is if the diagonals are perpendicular. So I could use slope to check to see if the diagonals are perpendicular. I'm going to go with the sides. I'm going to see if they're congruent. And the way that I'm going to do that is I'm going to have to find their lengths. And I'm going to go back to my graph, because when I find length on a graph, I like to do Pythagorean Theorem. I think that's the quickest and easiest way. So I'm going to zoom in. I'm going to start by finding the length of the top. So those same movements that I used in order to find slope, those are the same movements I'm going to use with the Pythagorean Theorem to get the length of the side. So right now, my focus is going to be to get this side length right here. So my work is going to be 1 squared plus, let me erase that, make this a little bit of a smaller font here. Okay, 1 squared plus 4 squared, is 1 and 4, equals the length of c squared. In other words, my side length squared. 1 squared is 1, plus 16 equals c squared. 1 plus 16 is 17. That gives me c squared. Lastly, I square root both sides, so the square root of 17 is your c value. Okay, so that's the top side length. That's square root of 17. Let's look at some of the others. Now for the bottom, since I also went up 1 and to the right 4 for the bottom side, it's going to use the same two lengths of 1 and 4. So I know that the bottom is also going to be the square root of 17, which is very typical for a parallelogram. Opposite sides are not only parallel, they're also congruent. But let me check the left and the right. So looking at the left side, I went up 4 and right 1. Same thing, it's movements on 4 and 1 that I'm going to use with the Pythagorean theorem. I've already done that. 1 squared and 4 squared. I've already done that. So that means the left side is the square root of 17. And the right side, same thing. It have movements of 4 and 1. So again, it's square root of 17. All of the sides are square root of 17. I don't need a calculator. If all the sides are square root of 17, I don't care what the exact value is. They're all congruent. So looking at my choices, a parallelogram that has all 4 sides congruent is either a rhombus or a square. Now, we right now know for sure it's a rhombus. We'd have to do more work to figure out if it's a square. But just by looking at it, it was pretty clear to tell. It's not a square. So we're going to choose rhombus. All 4 sides were congruent. Let's move on. Number 99. Last question before we're in the hundreds. Okay. ABCD is a parallelogram. Really important. Find the perimeter of triangle CED if the length of BD and AC is 17.8 and 25.4 inches respectively. Okay, that was a lot. Let's go back. Let's figure out what our ask is. Find the perimeter of triangle CED. Okay, let's look at our diagram and figure out what they're asking specifically. CED. Okay, so CED. They're asking about this triangle right here, which was formed when the diagonals of the parallelogram intersected. Okay, well, if I'm finding perimeter, I'm going to start setting up some information here. To get my final answer, I have 3 sides I need to know the lengths of, and I have to add them together. So I already have one side length. I have the 12.6, so I'm going to go ahead and I'm going to put that in. 12.6. Now I need the other 2. So let's take a look at what other information they gave us. Okay, they also told us that our 2 diagonals were 17.8 and 25.4 inches respectively. All right, let's take a look. Now, if they're telling us diagonal lengths, there's something that you have to know about the diagonals before we get started. In a parallelogram, when diagonals cross, and we've talked about this before, they cross at the midpoint. So E is the midpoint for BD. It's also the midpoint for AC. So I'm going to put some tick marks in here to show that my diagonals are getting split in half. They're getting bisected. So BE is congruent to ED, and EC is going to be congruent to EA. Okay, my diagonals are getting cut in half. It always happens with a parallelogram and everything in the parallelogram family. Rectangles, squares, rhombuses. Okay, so for all of these parallelogram shapes, it's going to have the diagonals get cut in half. Now, they told us that BD had a very specific length. Let's go back to see what it was. BD was a 17.8 and AC was a 25.4. Okay, let me go my diagram. So I have 17.8. And then the other one, 25.4. Okay, so AC is 25.4. Now those 2 make up the entire diagonal. My yellow perimeter here only uses half of those diagonals. So for example, if I wanted to get EC, EC is half the length of the whole diagonal AC. So I'm going to take 25.4, I'm going to split it in half, divide it by 2. $25.4 divided by 2, 12.7. Okay, so 12.7 is going to be the length of EC. It's half the entire diagonal. AE would also be 12.7, but that's not really what we care about. We're caring about the things that are touching our yellow perimeter. Okay, and the last one, 17.8, is the entire diagonal for BD. Well, what's half of that? So let me go to my calculator. 17.8 divided by 2 equals 8.9. Okay, so that means our diagonal was split into two parts that are each 8.9. 8.9 here, 8.9 here. Okay, focusing in on our yellow triangle, we have side lengths of 12.7, 8.9, and the 12.6 we knew originally. One thing I want you to note, that 23.1, it's a distractor. You did not need it. Okay, so let's put in the 12.7 and the 8.9 into our graphic organizer and get the final answer, which is the yellow perimeter. Okay, 12.7, 8.9. In the calculator, adding all of them together, 12.6 plus 12.7 plus 8.9 equals 34.2. So your perimeter, when you add up all the side lengths, is 34.2 inches, because everything was in inches. Okay, so an important thing that you had to know about this problem as well, midpoint. The diagonals cross at the midpoint. The diagonals get cut in half for any parallelogram shape. If you didn't know that, you wouldn't have gotten the 8.9, you wouldn't have gotten the 12.7, and then you couldn't find the perimeter of that yellow triangle. Also note, sometimes you're going to get distractors that have nothing to do with your problem. The top side length, that was a distractor. Okay, let's keep going. Number 100, what? Okay, let's solve for x. Now, there is one thing here that I want you to ignore, that x does not belong. It's a stray x. We don't know where it came from. Alien invasion. All right, so let's take a look at our triangle. Now, I want you to notice that there's really two triangles here that are overlapping. We have the little baby triangle, and then we have a triangle behind it. Now, these two triangles do have an important relationship. And the way that you're going to figure it out, it's going to clear the board again, is you're going to take a look at some of the important markings on this diagram. And the important markings are the parallel symbols. So if we know that two sides are parallel, we know about all these different angle relationships that appear. One pair of angles that we're going to see at the bottom here is a pair of corresponding angles. So corresponding angles. Corresponding angles are congruent. So that's one pair of angles that are congruent right here. One other pair of angles is the ones that are going to appear at the top. Same thing, they're corresponding, they're in matching positions. Well, if we have two pairs of angles congruent between the little triangle and then the big triangle, that means that these two triangles are similar. Why? Because of the AA similarity postulate. So, if they're similar, one thing I like to do with similarity, all the time I do it with similarity, is proportions. Proportions. Match things up, throw it in a proportion, any way that the things match, and solve. Now, what we're going to use here is something called the Side-Splitter Theorem. Instead of breaking out the two triangles and figuring out, well, what's the entire bottom side of the big triangle? What's the entire top side of the big triangle? We're not going to do that. Instead, what we can do when we have these parallel lines cutting up the sides of your triangle is we can just use the pieces. So, for example, I could use 7 and match that up to x. So that's like the little piece on the left and the bottom little piece on the left. I can use the 2 and match that up with a 4. And with that matching, I can go ahead and set up a proportion. So let's say 7 over x equals 2 over 4. We're going to cross multiply to solve. 7 times 4. 28. 2 times x, 2x. Divide both sides by 2, and we get 14 equals x. So 14 is the length of this piece right here. Proportions, proportions, proportions. When you see things are similar, just match them up, throw them into proportion. Okay, let's keep moving on. Number 101. Find the area of this composite figure to the nearest tenth. Use the pi button, not 3.14. Okay, so we're finding the area. And composite means that your figure is made up of a couple of pieces. And it's kind of just put together, fit together. They want your final answer to the nearest tenth. Okay, let's take a look at our figure. Let's see what it's made up of. Now, one thing I see is at the top, I have half of a circle. Okay, so I could find the area of that top piece, that half circle. Let me start laying down my ideas. So I'm going to find the area of that half of a circle. I also have this bottom piece, which looks like a trapezoid. So I'm going to find the area of the trapezoid. Once I have the two areas separately, to get the composite figure, I'm going to add. So let's start with the left. Let's get that little half circle. Now I'm thinking to myself, what's the formula for a full circle? Well, for a full circle, it's pi r squared. By this point, we should have that memorized. Times a half, or divide by 2. Same thing. And now for my trapezoid, I need to remember what's my trapezoid formula. Trapezoid formula is height times base 1 plus base 2 all over 2. Okay, you have to memorize both of these formulas. Not necessarily the 1/2 for the pi r squared, because usually we deal with full circles, but definitely the trapezoid formula. So flip to the back of your packet, write it down. If you don't have it, you need to know this formula. All right, let's plug in. So let's take a look at our circle. Now, right now, they gave me 8 centimeters, but that's for the diameter. My radius is what I always use in all of my formulas, which is 4. So I'm going to plug in the 4. 1/2 times pi 4 squared. Okay, let me simplify this a little bit. 4 squared is 16. So I have 1/2 times pi times 16. And then I'm going to do 1/2 times the 16, and I get 8 pi. I'm going to keep it in terms of pi for right now, and then deal with the pi all the way at the end. Let's take a look at our trapezoid. Okay, so for our trapezoid, we have 2 bases. The top base is the 8 centimeters. The bottom base is 12 centimeters. And the only other thing I need is the height. Now, they gave me the height of the entire composite figure to be 14 centimeters. I just want the height from 8 down to 12. To get this height, I'm going to have to subtract the height of this circle. Now, the height of the circle is this radius right here. And the radius, since we know horizontally the radius is 4, the radius vertically will be 4 as well. So 14, I'm going to subtract 4, and I'm left with 10 centimeters. So this height is 10. Let's use all this information and plug in. So now we have 10 times base 1, which is 8, plus base 2, which is 12, all over 2. Okay, let's start with the parentheses. 8 plus 12 is going to give me 20. So 10 times 20 divided by 2. Give myself a little bit more room to do the work. Okay, 10 times 20 is going to give me 200 divided by 2, and I get 100. So 100 is the area of the trapezoid. Don't forget, we also have to add the half circle. So, in my calculator, I'm going to start with the 8 pi. 8 times the pi symbol equals, so about 25.13, add 100 equals. Final answer, rounded to the nearest tenth, is 125.1. And for my unit of measurement, since it's area, we're going to do our centimeters squared. Final answer. Okay, let's move on. 102, last question on the page. Read it and then come back. Okay, so we have a parallelogram. It's called SWAN, and they give us all these coordinates. And they're telling us that two transformations are going to take place. What they want to know is they want you to state and label the coordinates of SWAN, double primed, after the entire sequence of transformations. So we're going to have to fill in the coordinates for each one of these letters. Okay, let's see what happened first. So SWAN undergoes a dilation first. The scale factor is 1/2. When you dilate with a scale factor of 1/2, your transformation should look like this. XY becomes 1/2 X, 1/2 Y. In other words, you're just going to multiply all of your coordinates by 1/2. So with dilations, you multiply by 1/2. Or you multiply by your scale factor, your K, okay, which in this case was the 1/2. So we're going to go ahead, we're going to write down all 4 of our coordinates. I'm going to write them vertically, and I'm going to do the entire dilation. So let's start off. S is at 2, -2. W, -2, 4, or -2, -4. It's important to be precise. A, -4, 6. Give myself a little room. And N is at -4, 6. Oh, I already did that one. N is at 0, 8. Okay, so let's go ahead and multiply. All of these will be multiplied by 1/2. So for the first one, S prime is going to be 1, -1, because 2 times 1/2 is 1, -2 times 1/2 is -1. W prime, -2 times 1/2 is -1, -4 times 1/2 is -2. A, -4 times 1/2 is going to be -2. 6 times 1/2, 3. And lastly, for N prime, 0 times 1/2 is just 0. 8 times 1/2 is 4. Okay, so that's after the first transformation, your dilation. And then it says it's followed, so the next thing that happens is a translation, which is a slide. It's going to slide over. It's saying you're going to slide 4 to the right, because if it says X plus 4, that means you're moving right 4, and then Y minus 2, which means you're going to move down 2. Since we decided not to do this visually and we're just going to rely on the rules, let's go ahead and just do what it says, which is add 4 to X, subtract 2 from Y. So I'm going to go ahead, I'm going to zoom in, and we're going to go ahead and work with these coordinates and do what it says. Adding 4, subtracting 2. So for the first one, I'm going to add 4, subtract 2. So 1 plus 4 for S double prime, 1 plus 4 is 5. -1 minus 2, -3. W double prime. Add 4, subtract 2. -1 plus 4 is 3. -2 minus 2 is -4. A double prime. Add 4, subtract 2. -2 plus 4 is 2. 3 minus 2 is 1. N. You know how to do it. I don't need to say it out loud. Okay, so these are all of our coordinates for our final answer. So you're going to fill all of these in. And now we've stated our coordinates. If we were to label the original, graph the original swan, then the dilated swan, you would notice that it looks smaller, should look half as big. And then when we translate it, it should look like it shifted right 4 and down 2. So drawing it in that little graph section there is great practice, and it's a great check to make sure you did the work correctly. Okay? You are done with page 20. Let's keep it moving.